So thank you everyone for joining us today. And what I'm going to start off talking about is PlantESP, which is a controller analytics solution for monitoring and tracking data. And there's a few things that I want to cover in kind of a brief time period here. I want to talk a little bit about who Control Station is, just in case you haven't heard of us before, and really focus on why you care about PID loops and talk a little bit about controller metrics, KPIs, forensic analysis, and kind of an architectural system for deploying loop analytics across not just an individual facility, but looking at multiple assets across multiple geographic facilities around the globe, and talk about a couple of different projects that we've worked on. So, we'll just kind of hop in here. Control Station, we've been around for quite a while. We were actually founded in 1988 at the University of Connecticut. The research lab where I did my graduate studies was the lab where the company was spun out of. It was actually originally called the LIPS lab, which was Lab for Intelligent Process Systems. And our first product was called PICLES, Process Identification and Closed Loop Experimental Simulations, or something like that. We loved acronyms back then, right? And we developed tools for monitoring control loops, modeling, and simulations, and so forth over the years. We've spun out of the university in 2004 as a for-profit company, have been growing ever since. And currently we support about 50% of the Fortune 500 manufacturers with PID tuning, monitoring, and analytical solutions. We have installations in 67 different countries now, with offices both in the US and Ireland. Control Station has a few different areas of expertise. We are focused primarily on the controller analytics side, looking at controller monitoring, so looking at control loops and looking at the behavior and performance of those systems. We are an agnostic tool, and I'll show you a few different architectural diagrams that show us how we can connect to a variety of different systems, not just PLCs and DCSs, but actual data streams from historians, from SQL servers, from all different types of silos of data to bring that information up and track it and monitor it at a central location. We also have tools that are designed to optimize PID controllers at the individual DCS and PLC level. But what I'm going to be talking about today is on the analytical side of looking at the data from your plants, from your assets, from your processes to be able to identify improvements in performance and opportunities. Additionally, we have divisions of our company that are focused on training and services. In fact, we support still a little over 200 universities with curriculum, software, and simulations to teach process control, so those next generations of engineers come out and have a little bit more practical experience on the process control and automation side, as well as services for doing audits and application startups and optimization and consulting services. So there is this really well-quoted paper back published in 2003. If you've ever been to any talk on PID tuning and monitoring over the last 20 years, these are the statistics that are quoted, right? And this is 2003. Something along the lines of 30% of control loops that are commissioned are still operating in manual mode, right? They're not in automatic, they're not in cascade. For whatever reasons, whether it be mechanical or tuning or just operator behavior, these assets are run in manual, which require operator intervention and operator control. They're the ones adjusting the valves and adjusting the pumps to do the control, right? Versus letting the PID blocks do it. Then there's a whole wealth of other issues associated with the controllers where controllers are so poorly tuned, they mask other issues, right? I don't know how many valves I've gone and done, flow and level control tuning on, where the controller was tuned to the point where it's trying to hide valve behaviors, valve stiction, and so forth. And you can't really fix that type of behavior with tuning. You just tend to hide it and mask it and make problems worse oftentimes. And then you have a fair bit of controllers that are actually causing more variability in automatic than in manual, where the controller's tuned unstable. And so there's a lot of opportunity. But these statistics, let's be honest, these are 17, 18 years old now, right? We had to have gotten better over time. Well, good news, bad news, right? We've gotten a little bit better. So PlantESP has been deployed, as I had mentioned, in 67 different countries around the world. This is an extract of that data. This is from a little over 150 different plants in a variety of different areas, a little more heavy on the oil and gas side. And what we can see is we've made a little bit of progress, right? We can say, look, we're running about 80% of the controllers in the correct mode versus 70. Well, we've gotten 10% in 18 years. I would have figured we'd done a whole lot better than that, but we're still trying to get to that point, because a lot of times, again, data's being captured, being stored, nobody's doing anything with it, right? There's not the monitoring in place. You know, there's where information, data rich, information poor, right? We heard that a little bit earlier. We've got a lot of data, not a lot of information. So to be able to take that out and do something with it, go out and identify the opportunities, get all of our controllers running in the correct mode. We have a lot of controllers now that are oscillating, right? We've got about half the loops that we've surveyed don't have any measurable oscillation in it, right? The other half have measurable oscillation. Now, 44% would be slight. What does slight mean? It's based off the total variability of the signal and how dominant the frequency is, but it's a slight oscillation, right? It would be one that's maybe not completely noticeable to operations, but it's still there. 5% of loops have significant oscillations. Those are the ones where you look at it and you say, oh my gosh, what the heck's happening, right? 5% of loops that we surveyed have oscillations that high. We have made good progress in control valves, right? With smart positioners, smart instruments out there, we're able to get better positioners out so we don't have as much stiction, right? We don't have straight up pneumatic, butterfly valves out there controlling critical flows, right? We've put better positioners on them, better valves, smart instrumentation, so we can get away from having valves that are sticky, that aren't tracking their targets the way they want. So we've made some good progress there. We do have opportunity for looking at variability, right? We still have surveyed over half the loops in the plant have a very high signal to noise ratio when it comes to error, right? So if you look at the error as a total percentage of the range of signal, right? Less than, 44% have less than 1% error over the entire range, but we're still looking at about a quarter of the loops have error greater than 5% of the range of the signal. That's a pretty big number, right? So what does this tell us? It tells us the opportunity is still there, right? Well, of course the opportunity is still there, right? We're still in this area. We know the opportunities are there, right? And now we've got data. Now we've got systems out there that can get us this information in a much easier fashion. So, PID tuning, PID control tends to be the thing that gets, left for last, right? Everyone comes in, loops get commissioned, they get started up, and they're running, and everyone just walks away. Like, it's working, it's good enough, right? So what happens when things go wrong? How do you identify that? Well, most of the identification is reactive. Operations team says it's broken, go fix it, right? By that point, all the damage has been done. We need to get into a position where we are now much more proactive in being able to identify the opportunities before the operations team notice and it impacts production. So we need to get beyond reactive and be much more proactive to be able to predict these types of scenarios. And so PlantESP is a tool designed specifically for monitoring all of your data sources to be able to identify controller opportunities. And we're going to go through the different KPIs and metrics and different tools that are within it. But from an architectural standpoint, what makes PlantESP unique is it can sit on top of a data historian layer. So the information is available to get extracted from the data, right? You already have the data. Let's turn that into information, right? So we can leverage all the data in the system. What makes that unique is now we can backfill calculations. We can take advantage of the months or years or weeks of data that you've already historized. We can go back and actually crunch the numbers to come forward with it. We've also built an entire calculation engine, visualization engine, and system administration tool that puts this whole package together. And you can consume this in a number of different ways. We have an entire web UI that I'll go through a few examples of, but we also have direct email alerts, reports that can be sent through email. And more importantly, we have an entire data schema on the back end that can be consumed by other tools. We're getting to the point where if you have a silo of data that cannot be accessed by other tools, that is a worthless silo of data, right? You need to be able to take this information and let it be consumed by other tools that build additional intelligence above it, right? Whether it's looking at, predictive analytics or artificial intelligence type modeling on top of other numbers, right? Or taking tools to be able to pull data into Power BI or to Seek or Elemental Analytics or all these other tools that are designed to consolidate silos of data to be able to identify trends. You have to open up your data, and all of our data is opened with a public schema that you can access to be able to get into the system. It also allows our system to be deployed across a very large system. It's not just a tool that resides at one plant and one plant alone. It's a tool that can live in a corporate enterprise layer and pull data from multiple historians. We can pull data from a central historian or historians that live at individual plants, and we can take all those silos of data together, combine it into one particular platform, one particular backend database, and we provide a web UI to our data, but we also open that up to third-party analytical engines to provide additional intelligence and information that you can pull from it. So PlantESP, again, is a web dashboard. It's designed to take all of the controller data and compute KPIs and analytics associated with it. So we're going to be able to calculate performance and metrics that tell you how your controllers are doing, how your plant is doing, how your enterprise is doing as a whole, being able to identify changes and troublemakers within your facility. So you're not waiting for your operations team to come in and say, hey, this controller is broken. Here's what you need to do to go fix it. We're going to say, look, here's a loop that's actually been changing and drifting in the downward projection. These are what the troublemakers here on the left are. You can click on the top one and immediately start to see, here's a loop that's actually dropped in performance, right? Not that it's poor, but it's changing and it's moving in the wrong direction. So it's very, very quick. The web UI is all HTML5. It can be accessed with any modern browser. You can access and control user access through Active Directory. So user permissions and credentials can all be automatically assigned. And again, the tool leverages existing data historians to be able to use that historical data. It also provides a very a strong system for outages. If the PlantESP server goes out because your entire data center lost power, right? When it comes back online, it'll connect back up to the historian and resynchronize itself and fill in automatically all the missing data that's transcribed. So even if you don't have a constant access to the data, PlantESP can still do the calculations and metrics. So you don't have real fast live data to the sites because they're remote. As long as your historian is being synced eventually, you can set ESP up to be able to do that kind of automatic syncing, even when you don't have a consistent, high-speed data connection out to the field. There are a lot of KPIs and metrics within PlantESP, but we focus on ones that are relevant to controller analytics. All of these are built into the tool. Configuration and setup of PlantESP is a very simple thing to do. You have a spreadsheet of loops that you want to import. You need the controller output, process variable, set point, and mode. You feed it into the tool. All the metrics, all the reports, all the dashboards are already pre-built. You just have to feed it a little bit of configuration information, and it can build out the tool. If you're using things like Asset Framework, that where you have an entire plant model already configured with all your data in there, PlantESP can leverage that data model and scan through it to be able to automatically build itself. And we're calculating metrics that go across a couple of different areas. We're looking at things like controller mode, right? Are you an auto? Are you a manual? Kind of simple stuff, right? We're looking at variability from target. How far away from set point are you? We're looking at things like saturation and dimensioning. Are your valves saturated? Are you running up against the limitation? How much controller movement are you having? Are your output travel higher or lower, right? We're trying to take these KPIs and metrics that you're visually inspecting on data trends. What's your current approach for identifying controller behavioral issues, right? Operations team says, hey, I've got a problem. You load up your handy dandy trending package, you start stacking traces and trends, and you stare at it, right? You say, okay, what mode am I in? Am I tracking set point? Is my valve saturated? Is it moving more? Is it moving less? All these are patterns that your brain is wired to visually identify, are the same metrics and patterns that the tool is built, that is built into it, so it can identify these opportunities. Be able to track things like the oscillation likelihood. Is the valve or is the process oscillating? We have metrics that track stiction. So do you have a sticky valve? Are the oscillations due to a valve that's stuck and it's trying to unstick itself and move around? We've also got real-time controller tuning. So all of your bump tests and output changes and set point changes are automatically identified to be able to generate models and generate tuning recommendations and suggestions based off of historical data. Again, all of this is configured, it's pre-built into the tool, and all of these metrics can actually build up into a health. That's what this heart is here, that you can adjust yourself. So if only you care about certain metrics, you can actually build a custom KPI within PlantESP called the health that you can weight the relative influence of all the metrics individually. So it's really a purpose-built tool for very quickly getting to your controller analytics. There's a number of different ways to visualize the data, right? KPIs themselves, just numbers, are hard to understand, right? They're just numbers. What does it mean, right? And so there's a lot of different tools to visualize the data and what's happening. We've tried to create gauges and a UI experience that's very easy. It's very intuitive. Tools are great, but if nobody uses the tools, they don't work. And so we spent a lot of time to make sure that our user interface is very clean, it's very easy, and requires very little training to be able to get into it, generate a report, find what you're looking for, identify the issues. We've got recommendations, we've got alerts, and different ways of looking at the data, such as heat maps, where you can pull up an area of your plant and you can get your simplistic red, yellow, green indicators of here's opportunity, here's loops that are oscillating, here's loops that are in the wrong mode, in a very easy to use interface. So what is the benefit here? This was a fuel gas to oxidizer flow loop identified in Loop Pro. It was never a loop that the operations team said, hey, there's a problem with it, but it was one that immediately cropped up to the top of the list on commissioning of PlantESP. It said there was a significant amount of output travel. The valve was moving around a lot, and it had a very erratic oscillation index, which meant it had very high oscillations and low and very high, but on average, it was oscillating a whole lot. So it was a really quick opportunity to say, hey, look, it's just a fuel gas, it's a flow loop. They're pretty easy to tune. So we performed our tuning exercise on it. We went and were able to maintain tighter control. So we were tracking the average error. AAE is average error. We're 88% closer to set point with a 98% decrease in output travel and 88% decrease in oscillation. If you're getting better control with moving the valve 98% less, you're going to, significantly increase the life of that control valve, right? All of that is opportunity. And it was an opportunity that wouldn't have been discovered otherwise. But how do you actually start to go a little bit deeper into your plant? So there's some capabilities within PlantESP for doing interaction analysis between your loops, right? So the big questions are, when you have an issue in your plant, how do you troubleshoot it, right? Again, I mentioned you pull up all these traces and trends and you start looking at it. Well, now how do you determine where the root cause is? Well, you add more traces to your trends, right? You start stacking all these trends up and you start looking at it and trying to line out the peaks and all of this stuff, where there are more advanced analytical tools that can help you along that path much more easily. So if we take a look at PlantESPs, we have a tool called Power Spectrum Spectral Analysis, where we can take the process variables and we can actually run spectral analysis, look at the spectral density, be able to identify frequencies within the data. So what we actually see here is this is data from a reboiler area, and the operators actually observed the disturbance, the amine still reboiler and the HMO inlet temperature control, which is this top loop here, and they identified that there was a disturbance going on. We then used PlantESP. It said, okay, here's all the loops that share that 54-minute oscillation. So here's all the loops that actually have that same fingerprint, and Power Spectrum identified that automatically. We actually are able to check those loops that we want to do a deeper dive on, and then we can hop over to this correlation analysis, right? Correlation doesn't necessarily mean causation, but it's a good way of understanding the relationships between your loops. Once you start taking a subset of your plant down, you can start to look at it and you can identify these opportunities, and you can identify leading and lagging relationships between the controllers to help answer the question, where does the oscillation originate? You got 100 loops, they're all oscillating. Where do you look at, right? Which is the one that you focus in on? And these tools are all built into PlantESP to help you very quickly identify those opportunities. And so we were able to identify the HMO heater outlet temperature as the leading cause and be able to go and focus our efforts into that particular area. So PlantESP is really designed to help you really understand what's going on in your plant, help you identify the controller behaviors that are present. What are the opportunities available? Which loops are the worst behaving, as well as tools for doing forensic analysis so you can deep dive to be able to look at which temperature controllers are oscillating or which flow loops and pressure loops to really focus in on where that problem originated from. I know that was a ton of information for me to cover in a very, very quick time. If you have any questions, my email address is on the slide. Also, feel free to come on by the booth over there. Our team is over there staffed, and you feel free to ask any questions. We can set up a demo of PlantESP of any of our technologies. So thank you, and I will answer any questions.
Great, Bob, thanks. I know we're kind of cutting it close into the next presentation, but real quick, again, I know you said visit your booth for more questions, but real quick, you may have covered this. Does it run in the cloud?
It can run in the cloud. PlantESP can run anywhere there's access to data. We have several installations that are running in Azure and AWS, accessing plant systems that are either available, that are already running in the cloud, or there have been secured connections into the data. Wherever there's data, PlantESP can run.